Okay. The final. The last. There we go. The final, the last, the very end of Advent of Code. So we ran into a little bit of trouble in the last couple days. My solutions run way too slowly, so I'll have to fix that at some point. Maybe I'll make videos on how that works. But today is the very, very last day. So, sea cucumbers is what we're doing today. Let's see. How many stars do I have? I have 40 stars. Hopefully we end up with 42 by the end of the stream. For reference, the script that I wrote yesterday to calculate the ALU is still running. So, there's that. So let's do CPR day 24, day 25. Let's get rid of this. And let's take a look at the problem. So this is it. The bottom of the ocean trench. Oh, that reminds me, the Space Webb Telescope went up like today or something, didn't it? The last place the slate keys could be. Your submarine's experimental antenna still isn't boosted enough to detect the keys, but they must be here. All you need to do is reach the seafloor to find them. It's completely covered by 2 herds of large sea cucumbers, and there's no open spaces. There's a lot of text here. They'll eventually pile up and leave enough space for, wait, did you say submarine? And the only place that many sea cucumbers would be is at the very bottom of the Mariana? There are 2 herds of sea cucumbers that are in the same region. One always moves east. The other always moves south. Each location can contain at most 1 sea cucumber. The remaining locations are empty. The submarine helpfully generates a map of the situation. For example, every step, the sea cucumbers in the east attempt to move forward 1 location. Then the sea cucumbers in the south attempt to move forward 1 location. When a herd moves forward, every sea cucumber in the herd first simultaneously considers whether there is a sea cucumber in the adjacent location it's facing. Then every sea cucumber facing an empty location simultaneously moves into that location. So, yeah. Due to the strong water currents, the sea cucumbers move off the right edge of the map, appear on the left edge. That makes no sense at all. And sea cucumbers that move off the bottom edge of the map appear on the top edge. Sea cucumbers always check whether their destination location is empty before moving, even if that destination is on the opposite side of the map. To find a safe place to land your submarine, the sea cucumbers need to stop moving. Again, consider the first example. In this example, the sea cucumbers stop moving after 58 steps. Find somewhere safe to land your submarine. What is the first step on which no sea cucumbers move? Okay, let's do it. What's the test input here? This? We could parse into a grid. Right. I don't think there's any functions in ND array that would help us though. At least I can't think of any. Because we can't do neighbors across the boundary anyway. Be quiet, laptop. So if we can't do numbers across the boundary, then we're probably just going to use a B-tree map. And they only move in 1 direction, so we only need to check 1 index, which is great. We do need to keep that index around. Let's get rid of this. Get rid of that. Let's drop a bunch of this stuff out of here for the instructions and whatnot for the ALU. God, the ALU one was so frustrating. I'm thinking about making a an Advent of Rust for next year, with some of the opinions that I have from doing Advent of Code for the last few years. Like, it would be really nice if the inputs and the outputs were like there for you to be able to create tests with. If things were completely explained rather than like hoping you figure it out from the input. Like yesterday's was super frustrating, right? Let's just do unit here. This is just a vec of units for the moment. Actually, I don't need these anymore. Let's just do to do. Yeah, like yesterday's was super interesting because super frustrating actually, because the way that everybody solved it in the end was they manually went through the inputs that they had and they like decompiled each of the what are effectively assembly instructions. And then they built up their answer from like manually decompiling the assembly stuff in the input for their specific program, which is like totally not, I don't know. It doesn't feel like there was much coding involved in that. Like this thing, people just manually went through this whole list. Just gonna chop that out for a second. Okay, so we need to parse this grid. I want to parse it into a B tree map, I think, with the positions. I mean, the other option is to stick it in a 2D array. And then we can still iter over it. So maybe we do that, actually. If we indexed iter, I'm just thinking about it now, and like, yeah, the 2D array kind of helps in terms of like we can .get with a tuple for the specific like grid points, and we can index iter, which just hands us all the grid points, but we can just as easily like enumerate and get the indexes. Which we have to do anyway. And because we have to check like from the right hand side to the left hand side and the bottom to the top, I don't think that unless we cycle it, which yeah, isn't going to work. Yeah, so I think we're just going to do like a vec of vex or whatever today, or a B tree map, I guess. I think the B tree map is probably the best option, because then it means we can arbitrarily pull stuff out without having to worry about, well, we can still do indexing, right? .0.1 versus .get. The B tree map will keep everything sorted, which is nice. I don't know that we need that though. So maybe we'll do the simple thing. We'll do a vec of vex. So let's do let input. Let me pull up the test input while we're doing this so that we can have a nice little view of what we're actually parsing here. So input, we're going to have v and dot and right. So Do cars equals many one of, is it one underscore of? I always forget. One of v dot right. Let me pass the input in here, and we handle it with the question mark. This is going to be a line. So we're going to do separated list, new line, many one, those things. Separated list 1 is probably what we want here. So we get grid. I think that's it, honestly. I think that's the whole thing. What a parser to end the year on. This is going to be a vec of, let's make these what are they called? Cucumbers. So let's do enum cucumber. Let's do right and, or let's do, I don't know, east and south. And then this will be some cucumber. Because, oh, that's not, I've been doing that every day for the past like 4 days. I think I'm just getting tired of these problems. I keep making these very simple mistakes. Okay, so we have not an optional, an option cucumber. So we have an option cucumber. That means we need to do grid.map. We have a string here, right? If we check with Rust Analyzer, it should tell us that at some point one time. I guess they're cars, right? So we'll put a C here. And then we match C. For dot, we return none. For right, we return cucumber east. For V, we return cucumber south. And for anything else, we panic, invalid input. That's cucumber east. Oh, right, because these need to be some cucumber east. So that's that. And then why is .map not working? Because we need to .iter before we can map. So map is a function on iterators, or it's a function that is on the iterator trait. It's not on vex. Then we collect this back into a vec. Let's just do collect, actually, because I think it'll pull in. If we cargo test day 25, we get some kind of error. Vec auction cucumber cannot be built from iterator item equals option cucumber. Because I need to map on the map. Grid.iter.map. These are not characters then. This is .map inner. Inner.iter.map. And that's kind of the 2D array effect there. Like, and because we have so this is the strength of Rust inference, right? Because we have the function return type defined, collect will know, hey, we need to put it into that kind of thing. It gets a little confusing if you do collect like this a bunch, because we're not specifying explicitly the type that is being collected here, which is probably best practice. But I did want to show off that Rust can actually figure out just from the function signature if we're returning this value that which of the collects in a nested collect situation should be what values. Would a matrix make the cycling easier, move off bottom and end up at the top? I think I'm just going to do indexes, honestly. I think I'm going to clone the grid. And the only thing that I can think of the matrix making easier is the like indexing into a specific spot. Like the cycling won't be easier, right? Because we still have to get all the indexes, and then we have to operate on a mutable copy of the grid. So we still have to index into the grid, and we have to index into the grid anyway. So I don't like using using ND array feels better, but I want to show off doing it with the Vex today because I feel like the Vex are how most people would approach this problem. And I don't think that ND array really, it's not like 10 times better, right? Like the Vec of Vex is kind of the simpler case of the ND array, but the ND array doesn't give us like really useful functions. We still have to loop over everything. We still have to make a clone of the grid. Like we don't have some kind of Windows thing that gives us 0 and 1, but also like 9 and 0, you know? Unless there is one and I don't know of it. If there is, then we should go do that. But okay, so we have the grid. It's a Vec of cucumbers. And in this, we just need to write a function called step that takes some cucumbers, a reference to this, and then returns this. Right. Nope, I forgot that there's an extra little thing on the end there. So if we have one, then for row in cucumbers dot iter dot enumerate, right? It says I row because we enumerated, and for column or I column, right? I column in row dot iter dot enumerate. Enumerate is super useful. Enumerate gives us the index of everything that we are iterating over. For some reason, it is not happy because it thinks this is the return type. Let's just return cucumbers here for a second. Cucumbers doesn't have debug on it, so we do need to do that. And then that's probably a use after move. Vec option cucumber because of the return type. Oh, it's a reference, that's why. Let's do new grid equals cucumbers.clone. Then we return new grid. Expected struct found a reference. Why is it a reference? I mean, I get that I'm passing a reference in, but this clone should give me ownership over this, right? If we clone it into a new one? I'm a little confused as to what I just did. Cannot move out of new grid, which is behind a shared reference. So we're not cloning the interiors? Is that what the problem here? We can solve that easily. It's a little awkward, but we can. Let's do this instead. Let's build up a whole new grid. Let's do let new grid equals vec. Right? And this is going to be a mute new grid because we have every item here that we need to iterate over. Let new row equals vec. You're shadowing I in that for loop. I am shadowing I in this for loop. Let me go grab some water for a second, and then I will fix the shadowing the eyes in the for loop. Thanks for the call. So we're shadowing the I in the for loop. And what is this? X? No, this is Y. I'm going to call this row index. And this is call index. I'm going to start spelling these out entirely because that makes more sense. So let mute new row equals vec. Why is vec a problem there? That's weird. Oh, can't infer type parameters. Yeah, that makes sense. So let's just pull this in then. This is going to be of type this, just so we can be explicit here. And kind of just document it a little bit. If we do need to do the inference, then we can do the inference. It's fine. So let's get rid of this. Let's get rid of that. So now we have the row index and the column index. We've enumerated over all of the grid positions. We need to do let next pause equals cucumbers dot get row index unwrap because it has to exist dot get call index unwrap. Let's see if Rust Analyzer can pick that up. Yeah, option cucumber. So this option that came into this cucumber, so what I did is I indexed into the vec with get, and then I unwrapped it and I indexed into the column and I unwrapped it. The reason I'm going to do that is because here I'm going to expect row index to be valid and expect call index to be valid. And this way we get a little bit more error messaging. We are just going to panic here because we don't really need to return the errors. We expect that in a valid operation of this program, that all of these indexes will be valid. If the indexes are invalid, then we have a big problem because one of our base assumptions about how this program operates is broken, basically. So this is the current position, which we already have. So row index. Actually, we need to detect which thing we have here, right? So this column is actually the. I'm going to call this cucumber. Match cucumber. Fill match arms. So we get this. And then this next thing needs to happen here. Well, it needs to happen here regardless, actually. So it needs to happen to both of them. Well, no, it doesn't, actually. So for some, we do this here. And here we're going to do, I guess, the same logic for both of them, right? So really, this is just going to be cucumber, and this is going to be slot or whatever. And here, the next position is going to be this, and the difference is going to be whether we get the row next or the column next. We do need the distance here, so let row max index equals cucumbers dot length, right? I think it's length minus 1, actually. We're looking for the index. Let call max index equals cucumbers 0.length minus 1. So this is where the ND array stuff would come in handy, right? Because we could do axis 0.length and axis 1.length, and it would clean this up a little bit. Because doing this like random index and random checking, yeah, and then like the minus 1 and whatever, it's a little eh. This is caffeinated strawberry juice, by the way. Absolutely amazing. It's amazing what people invent. Instead of bean juice, I'm drinking caffeinated strawberries. Okay, so either way, I think we need to do match cucumber, right? And we fill the match arms here. If it's east in the row, we keep the row index. If it's south, it's row index. Is it AHA or something else? No, it's from Starbucks. Do we do row index plus 1 mod row max index? If it's mod row max index, then it's not going to be this, right? And this is not going to be index. This is going to be length. Right? If we mod this, so if we have like 9, if we have a length of 10, we have the number 9, We go up 1 to 10. We 10 mod 10. We get 0. And we should be at index 0 for the next position. So I think this is right. We're going to do this again right here. And these need to change to... am I using call or column? Call index, call max length. So it's a little bit verbose, but it's very explicit, right? So if we do a dot get here, we're doing a dot get on either the next row index or the next column index. Basically, you know, east or south. And we do the mod basically we do the mod to wrap around to the beginning as well. So this is the next position. We may or may not have a thing here. Next position. We'll either have a cucumber or it won't. If it doesn't have a cucumber, then we move. If it does have a cucumber, then do, or yeah, set. You set current at current. I'm gonna call this don't move. Move and don't move. Because if we have something in the next slot that we're trying to go to, we can't move this one. So none. If we're going to not move, we are going to new row dot push. What is the current one? Cucumber? Replace match with if let. Why are we... Why would we replace that with if let? I think that's a bad suggestion. This needs to be some cucumber. Cucumber needs to be cloned because we're moving it. I guess we could move all of these and we wouldn't really need to matter. What am I doing? It doesn't implement copy. It should, right? I mean, like, we didn't say it implemented copy, so that's fine. We didn't implement clone or copy. I need a little bit more caffeine. So, like, we could do this, and it'll deref to the copy. F. So, new row push, some cucumber, and then none. We move it, so... I think we new row dot push none, right? And then we not to owned, thank you. New row dot push some. Well, next pause is nothing, so the current cucumber needs to go into the next position. So if that's the case, then the next iteration, we will have none here. So we match, and then we just do nothing. We can't do nothing, right? This is going to be an interesting one. Okay, so we have a cucumber, right? We've moved it forward. We've set the current position. We've set the next position. I think if we check the length here, right? If what do we call this index? We matched on the slot. If there's no cucumber in the slot, we could have put one in. If we have put one in, then oh, you know what this doesn't account for? I need to do indexing. Actually, I can't build up the row like this. I need to clone it. Let's not do that then. This is new row. Is there new call? Did I do new call? I don't think I did. So if it's none, we just don't touch it then. So here, new grid is... That's why it wasn't working before. Oh, I'm so silly. My face, it hurts. I didn't implement clone, so it couldn't clone before, and I just wasn't paying attention. That's why you read your error messages. Okay, so if that's the case, we have the next position. Hey, happy holidays. Ate too way too much, so things are going well. Nice. Good to hear that, Nikki. Glad you're having a good day. So slot cucumber, cucumbers.get, expect, match next position. If we have a cucumber in the next position, we need to set the current position to the same cucumber. So actually we do nothing, right? If we have a clone. And then if there's nothing, then we set the current index what is it? Row index, call index, none. We dereference to set this. These don't exist, so we do this. Oh, come on, just get in there. Option cucumber cannot be dereferenced. Why not? Because I didn't implement deref? Let's do this. Let's be more explicit. That should work, right? Yeah. So we did the same thing we did above. These, again, can be expects, which lets us put a valid, like, value. This is row. This is call. Rust Analyzer has given up on this line, which is fine. I've given up on that line too. And then we do this again, basically. But instead we get this one here and this one here. I guess we could do these like up there and then not have to recalculate them, but I didn't do that, so whoops. And then that equals some cucumber. And that theoretically should do it, right? And then here we just do nothing. Right? Like at that point, oh no, it didn't give up on that line. What it did was give up because I had a syntax error just sitting on randomly down in the rest of the file. So on none, we do nothing, et cetera, et cetera. Here we're saying that we're returning these. Let's return these and like did move basically. Which we can actually detect. We don't need that. We don't need to return the value because we can do an equality comparison. We do need to implement equality on this thing, but it's fine. So here we have process part one, assert one, Yada yada, tons of steps. We'll call it 58 steps. Here we will do for step in 0 dot dot. I called it step. I shouldn't call it step. Step count and 0 dot dot. Let's do 1 dot dot. I don't want to do the +1. Let's do step cucumbers. New. Let's set let mute cucumbers. Let's just shadow everything today. Equals cucumbers dot clone, so we have a new copy of it, right? New cucumbers equals step cucumbers, which we pass in as a reference because we want to keep them around, because the thing that we need to do is if we did this as an iterator, we could have just done a while loop. That would have been fun. If new cucumbers equals cucumbers, then break, else don't break. We haven't set up equality yet. That's why we're getting a little red squiggly over that equality on the cucumbers. This is going to equal 0 for a second. This is going to be also mutable because we're going to change it. Inside of here, we do final step count equals step count. And then this will be final step count. And up here, we'll do equality on the cucumbers. So eq, partial eq. Again, we need to do partial eq, which in partial eq contains all of the functionality for doing equality. And eq, EQ, is just a marker trait to be like, hey, all of the cucumbers can be equal to all of the other cucumbers that are exactly the same. Partial equality is like not a number equals not a number, where they don't equal. And then full equality is EQ, is a marker trait for like, if not a number were equal to not a number, then that would be a full equality. You can think of these as like JavaScript equality versus like the equality you want. Cargo test failed write 6. 6 is wrong. Figured out why my code didn't work after a refactor. Perfect. That's wonderful. Our code is also not working. I guess technically speaking, we could have exactly the same cucumber setup, right? So let's do a display impl. Impl display. Wearing your glasses every time matters. We're going to do a display implementation. Actually, we can't do a display implementation because we didn't type aliases or anything. So we're not going to do a display implementation. What I'm going to do is write a function called print grid, which is going to take a grid, which is a reference to all of these cucumbers. And is just going to, for row in grid dot iter, for call in row dot iter, match call. There's an order of east then down, which might also be the issue. Oh, you're absolutely correct. I'm still going to write this display. Cucumber east. And this is going to be this. This is going to be dot. And south. I forgot about the arbitrary ordering constraints that Advent of Code always loves to drop in there. So we print all of these. And then let's just do new line on the top, I suppose. So I guess we don't even need to do that, do we? So after this, we do print new line. And then we can just print the grid. So for every process part 1 for step count, we'll print grid, new cucumbers. And that should print out. It won't have any spaces between them, but it should print out. Let's make this a little bigger. And then let's do... I should have made that a format instead of a print grid. Print grid is such a weird choice. It's going to print an empty line. So each of these are the grids. We'll print line, grid, step, this. So display formatter, step count. And now we get a little count right above each of the grids. So grid step 5 is this grid, et cetera, et cetera. This is post grid step 1, which is going to be wrong because we did this over here incorrectly. So we do this loop here, right? We need to do the whole thing for east and then the whole thing for south, right? So this is going to be a double clone and a redo, I think. Today is one of those days where the delta between running with and without release is huge. Yeah. So let's do step and let's take direction as a cucumber. So if we take a cucumber here, right, and it goes either east or south, because this whole thing can basically be done effectively in 2 passes for each step. So we do pass 1, we get the new grid, we do pass 2. Actually, you know what actually confused me? Is that they said everything moves at the same time. So in a situation like this, after 1 step, only the rightmost sea cucumber would have moved. After the next step, 2 sea cucumbers move. So let's see. Right. So this should not move. So east moves, and then south can't move because east has already moved. So it is 2 full passes. It's a pass on the modified grid. It's not a pass on the original grid. It was an interesting word choice. That is one way to describe the way Advent of Code problems are written. Was it simultaneously was the wording they used? Every sea cucumber in the herd first simultaneously considers whether it's a sea cucumber in the adjacent location. And then every sea cucumber facing an empty location simultaneously moves into that location. Whatever. We pick the direction. We do, what do we do here? We do, if we're operating on east, then when we do this, some cucumber, so both, if Matt, if let cucumber not equal the cucumber we're operating on, so direction, continue. And this is going to be like, I should have used shared references here. And then step needs to take cucumber east. Right. And this returns cucumber south. So we're just going to be real sneaky here. We're going to step. Ta-da. Cucumbers. I guess it is a reference, isn't it? Failed. We still get 6. So let's check against the intended output, see what we're doing here. Oh, that's not, which test did I pull in? Is that actually, was this accurate the whole time? The test input is the V right, VV right. V right, VV right. Okay, so it is this one. And that means this is our intended. So this should be, this should have moved down. It did not. My indexes are off, I think. Because look at these two. These two look like they're moved over to the right. Right? I spent an embarrassing amount of time looking for the down caret on my keyboard while writing parsing code. I only know that because I've seen it before, Nikki, so don't feel too bad. Let's make sure my input is correct as well. Let's see, lib. Okay, so our initial state and our test input should be exactly the same. Come on, VS Code, you can do it. There we go. They are. So after step one, what's going on here? I think our indexes are off. Let's print out both of the grid steps instead of trying to be tricky here. Okay, grid step initial. I am not printing this out yet. Let's do this. Let's do east grid. New cucumbers. East grid step, south grid step. I bet you I either flipped my binary operation for testing which one we should be doing, or the east grid step one didn't move at all. It's exactly the same one. Am I printing out the original? Doesn't look like it. But grid step one is not doing anything. And then south moves from here to there. Which looks like I'm moving it to the right. It looks like I'm going south and east in south. That's weird, right? So for the current cucumber, if it's not equal to the direction we're trying to go in, then we skip it. If it is equal to the direction we're trying to go in, then we get the next position. We match on the next position. If it's something, we do nothing because we can't move. If it's nothing, then we grab that. Oh, am I modifying the original grid? No, I'm modifying the new grid. That's good. Big questions. Big questions. What did I do wrong? Row index is going to be 0 through 9 or whatever, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 here. So 0 through 10. Same thing here. Let's do some debugs. Let's do row index, call index. Print line. Not processing. So we go all the way up this giant list. I should probably have just changed the iteration number. That's a massive list. Okay, so if we look at the initial 0, 0, not processing because it's a down. So the first one we should process is 0, 1, 2, 3, 4, 5, right? So 5 should get processed. Let's debug, next pause. Let's make this step counter go 1 to 2 so that we only get the first iteration. Because this is going to be a lot of output. So the first one we get is east grid step 1. So at 0, 4, we have an east. At 0, 5, we also have an east. Why do we have east at 5? Right? That's wrong. Because this is the next one. So our indexing is off for some reason. Did I mess? Am I not doing +1? I'm not doing +1 for any of these. No! Did I forget to add it? Why did I do that? We're now only processing the relevant ones, right? So here and here. Wait, no. Row index. This is the one. This is the one down here. This is the one that needs to change. This, no, it's not. It's not the one that needs to change. Yes. So south needs to increase the row. East should be brain exploding. This is always going to be what? We match the cucumber to get the next position. If it's east, the row index stays the same. If it's east, the call index changes. Call index here and here. That's the change that we need. Right? And then grid step 1 is supposed to look like this. And it does not. We were so close. I think I did the same thing down here, right? Because I now need to change this logic in 2 places. So here's the other one that I need to change it in. And now, right down, right. VV, right, VV. VV, right, VV. Right V, right, right V, right V, right V. Yep, looks good to me. Let's get rid of these debugs and run it. So print line somewhere around here too, right? So let's do 1 dot dot. Cargo test. Hopefully we get 58. We got 58. Let's cargo run. Release bin part 1. And we panicked. Because I have an empty string for my input. I swear. I swear. One of the things that I want to do actually is do like a fetch input for the like cargo generate. So like it's a cargo generate thing, but it also includes some tool to like fetch your advent of code input. Oh no, not the not processing. Not. Let's get rid of that. 360. That's some bullshit is what that is. Oh wait, no, it's it's the input. I thought we were still running the test. Oh my. These problems are starting to get into my head. 1 gold star, we got it right. Great. Our indexes were just a little bit off. Slay keys detected. Okay, according to the console, the keys are directly under the submarine. You landed right on them. Now you just need to get them to Santa. Remote start. You can start the sleigh from the bottom of the ocean. You just need some way to boost the signal from the key so it actually reaches. Good thing the submarine has an experimental antenna. You'll definitely need 50 stars to boost it that far, though. Okay, well, the final problem for part 2 is to finish everything. Wonderful. They discouraged that because of all the edge cases and not wanting anyone to fetch too often. You know what? I'm not sure I care what they discourage right now because the way they write these problems is incredibly difficult to read. And it's almost intentionally hiding information and utility. But again, I think I'm going to just create a different one next year. And something that's a little bit more targeted towards people who are learning new languages. Something that's a little less targeted towards like, oh, this is a coding problem that you have to manually go through your own input and parse your own program and decompile the thing. You think the display is broken? You definitely have less than 49 stars to go. Yeah, because as we've talked about previously, the person that made the site, this is probably hard-coded content. 49 stars to go. Whereas they have the dynamic one right here, but they don't match it up with, like, they're highlighting 49 stars, but they don't highlight the actual number. The actual number is 8. I have 8 more to go. But we've talked about that previously, because this thing is, like, hard-coded to, like, some arbitrary character length. So if I make this window smaller, it doesn't, like, it doesn't wrap. I think some of these are intentional stylistic choices. Some of these are probably just like it works, so why change it? But yeah, I don't have the 50th star because you can only get the 50th star by doing all of the other stars. We were pretty successful. We did everything up until day 18, which is the first day I got my booster shot. So 18 is snailfish. 19 we didn't even try because I had the booster shot and the flu shot, and I was too tired to stream. Day 20 we got back at it very strong. We got both days. 21 and 22 I don't remember. I guess my runtime or something is too slow. I know for 23 and 24, like 24 isn't a programming problem. Like you can code all the instructions for the ALU and it's still like you still can't solve the problem without having additional insight and view into what what the input for your program is doing, which is really frustrating. 23, I feel like, was similar. I wrote the code, it works. It just runs too slow because I did what they told me to do. So I have to go back. I have to do 23 and 24. We wrote the right code for it to operate. 19 was pretty fun. It's a long one. It turned out solving tiny parts of the problem worked out well. I'll read this one. I don't think I'm going to do it today. I think today I want today to be a short stream. And I probably won't do it tomorrow either. I'll probably take a little bit of time off before we do 19 again. I'd be very interested in your ideas about how to make it more friendly, Derek, because I think that I actually am going to do one for next year. So I like the language agnostic and the parse input parts, but the other parts are rough for sure. Yeah, I agree. I think I have a list started of the things that I would change. And I think I'm going to do it for next year. So I just need to do a little bit each time over the next couple months. And then, yeah, I'll launch it next year. But yeah, we can talk about that in Discord. You're in voice chat a decent amount. Okay, so a bunch of stuff here. These are a bunch of coordinates, 79 beacons. What is this problem actually? I'm only reading the problem. I'm not going to do day 19. The beacons and scanners float motionless in the water. They're designed to maintain position for long periods of time, each will yada yada. If a scanner is at XYZ, there are beacons at whatever and whatever, then the scanner could report that the first beacon is at 1000, but would not detect the second beacon at all. Unfortunately, each scanner can report the positions of all beacons. The scanners do not know their own position. The scanners and the beacons map a single continuous 3D region. This region can be reconstructed by finding pairs of scanners that have overlapping detection regions, such that there are at least 12 beacons that both scanners detect within the overlap. By establishing 12 common beacons, you can precisely determine where the scanners are relative to each other, allowing you to reconstruct the beacon map one scanner at a time. For a moment, consider only two dimensions, 0, 2, 4, 1, 3, 3, and -1, -5, -2, 1. Drawing X increasing rightward, Y increasing upward, scanners as S and beacons as B, scanner 0 detects this. Okay, so we're in a 2D space. And this scanner detects these beacons. Scanner 1 detects these beacons. In this example, assume scanners only need 3 overlapping beacons. Then the beacons become visible to both scanners, overlap to produce the following complete map. Unfortunately, there's a second problem. Wait, so this is like a super basic version where 2 scanners scan the maps they generate, overlap, and then that's the location of the beacons. But there's a second problem. The scanners also don't know their rotation or facing direction. Due to magnetic alignment, each scanner is rotated some integer number of 90-degree turns. Thank you for making them 90-degree turns around all of the X, Y, and Z axes. That is, one scanner might call direction positive X, while another scanner might call that direction negative Y. In total, each scanner could be in any of 24 different orientations, positive or negative X, Y, or Z. And considering any 4 of the directions up from that facing. So 4 options for each of them. So 3, 6, 4, yep. So positive X, positive Y, positive Z, negative Z, and then a rotation of either quadrant 1, 2, 3, or 4. For example, here's an arrangement of beacons as seen from the scanner in the same position, but in different orientations. So we get a number of points. Those points go into I guess like they would go into a B tree map or something, right? By finding pairs of scanners that both see at least 12 some of the beacons, you can assemble the entire map. For For example, consider the following report. So we just need to rotate them until they're all matching. Because all coordinates are relative, in this example, all absolute positions will be expressed relative to scanner 0 using the orientation of scanner 0, and as if scanner 0 is at coordinate 0, 0. Scanners 0 and 1 have overlapping detection cubes. The 12 beacons they both detect are at the following coordinates. The same 12 beacons in the same order, but from the perspective of scanner 1 are this. Because of this, scanner 1 must be at whatever that point is. So we get basically a bunch of points and a bunch of other points, and we have no idea whether they're rotated or flipped or anything. 4 overlaps with 1. 12 beacons they both detect are those. 4 is at whatever. Yeah, this seems like a long problem. So the puzzle input is going to be what? Like a list of scanners and beacons? Okay, so there are more than 12. Was it 12 or 16? 12 beacons. So 12 of these overlap with one of the others. 12 of these overlap with one of the others. 12 of these overlap with one of the others. We don't know which one. And the coordinates are actually going to be different and off, but all off by the same amount. So you need to like overlay these scanners on each other and figure out these aren't guaranteed to be the same beacons in the same order. So you would have to compare them. My plan for this one was essentially distance maps and finding overlapping distance, but it was definitely F on this problem. Yeah, we'll do this one day. I'm not going to do it today because I don't want to get into another problem, and I want today to be light. 36 scanners. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20, 21, 22, 23, 24, 25, 26, 27. So there's 27 beacons for each of these scanners. Each of the scanners has 12 overlapping with another one. The overlapping points will be one of 27 different orientations. So each of these points has 27 variants that it could be. And then you need to compare those. My impression is that these are distance from the scanner. So we don't know where the scanner is, and we don't know. All we have is the distance from the scanner to the points. And the points all need to line up in some way. So interesting. All right. Well, I'm not going to do it. I don't know if there's a better way, but I kept rotating a block until it overlapped with the final map, after which I merged it into the final map. Yeah, I feel like something like that could work. Scanner 0 is 0, or scanner 0 is 0, 0, right? So these are all in the correct spots. Or did they lie to us? So yeah. So yeah, we start with Scanner 0. Scanner 0 is the start of our final map. It has the correct, right? It's the first correct one because everything is relative to the orientation of Scanner 0. So yeah, anyway, we will do that at some point. We ended Advent of Code with 41 stars this year. So that's pretty good. I mean, I'm reasonably happy with that. Like 41 is a decent amount. Only 123 people got day 24 part 2. Wow. We're talking day 18 part 2, only 150. Wait. No, that's 156 people of the people who solved it didn't get part 2. What is that number? Oh, this is only completed the first half. This is such a weird number to show. Why isn't it like 21,000 completed both parts and then like 20,950 completed part 2? Why? Why is that the number they chose? I mean, I guess, but like, why is the people who only completed the first half the second half of the display? You know, like the visualization here is like, here's everybody that completed part 1 and 2. And then to the right in the second slot are people that only completed part 1. Anyway, we're done with Advent of Code for this year. Maybe I'll make a separate video on day 19, or we'll do it sometime in January. It's not going to be... well, I don't know. Maybe I'll feel like streaming next week. Maybe I'll do it next week. Who knows? But I will let people know on Twitter and YouTube. I'll have scheduled streams. I think I'm going to start streaming again in January. So if you're interested in Rust and cargo generate and stuff like that, then yeah, I'll see you in January. Otherwise, thanks for hanging out. It's been 25 days of Advent of Code, and that was a lot. Have a great rest of your day.